Welcome to Maths and Science by IITN channel. In today's lecture, I will be taking up a very good example clearing many concepts in domain, range and plotting of an excellent function which is a ratio of two logarithmic functions. Function x is equal to ln of x minus x cube divided by ln of x plus x cube. Both numerator and denominator are different and they are the logarithmic functions. Function x is the ratio of these two logarithmic functions. Here we have to find out the domain, range and we have to plot. This is a very good example useful for Maths Olympiad, JEE Advanced, JEE Mains and also for CSIR Mathematics. For plotting, we have to understand the domain and range of this function and the behavior of this function, how it behaves for various values of x. Domain means the values of x for which function x is defined. Range is within the given domain or obtained domain, what will be the value of function x. And plotting will be by using the domain of x. Plotting, we will do the plotting of function x and that is plotting on x and function x graph. Function x graph. Function x is on the y axis and x is on the x axis, value of x. Now let us do the problem. It's an excellent problem. Please pay attention to each and every concept which I am defining here. Concepts of logarithms, concepts of finding the domain of ratio of two functions and range and plotting, and it's a beginning of understanding the limits and continuity. Please pay attention to it. At the end of this lecture, if you feel this is added to your knowledge, value addition to your knowledge, please hype, share and subscribe to my channel. Let's move forward see till the end so that you will get grasp of many concepts in this. Let's move forward. What is the question given? Question is find domain, range. Domain is input, range is output, where function x is defined of function x, domain and range of function x, where function x is equal to ln x minus x cube whole divided by ln x plus x cube, and also plot the function. Let us try to solve it. Function x is the ratio of two functions and hence we have to divide into numerator and in denominator. Now let us study the behavior of numerator. In numerator, what is numerator? ln ln of x minus x cube. As far as x cube is concerned, we know the domain will be x value it can take from minus infinity to plus infinity on the real line. The main crux of the problem is to find the domain where this value, that is ln x, for what values of x this is defined. Now, this particular value is there both in ln x is both in numerator and also denominator. Now, ln of ln x. Let us study this. Will be defined under what conditions of x, under what values of x, this particular ln x is defined. We have to find out. ln x, from the elementary logarithms, we know ln is nothing but natural logarithm. It will be defined, ln x is defined for x is greater than 0. If x is less than 0, if x is negative, ln x is not defined because negative logarithms are not defined. Please understand. Log or ln of negative values not defined. It implies ln x is defined when x is greater than 0. But it's not the end of the road. We have to take 3 logarithms. This is only the innermost. Now, next is ln of ln x. When it will be defined? When ln x itself is greater than 0 is defined. Logarithm of logarithm x. When ln x is greater than 0. When ln x will be greater than 0, ln x is greater than 0 means x is greater than 1. Ln x greater than 0 implies to the base e, x is greater than e to the power of 0. That implies x is greater than 1. Please understand, this is the second concept. Ln x is defined only when x is greater than 0. Ln of ln x is defined only when x is greater than 1. Now, that is not the end of the road. We have to find out ln of ln x. This value is defined when x is greater than 1. That implies this particular value only, ln of ln x, is defined when x is equal to greater than 1. That means ln of ln x defined when x is greater than 1. Ln of ln of ln x is defined when x is greater than e. ln of ln of ln x is defined when x is greater than e. Because ln of ln of ln of x is defined when ln of ln x is greater than 0. That implies ln x is greater than 1. ln of ln x is defined when x is greater than 1. That implies x is greater than e to the power of 1. That implies x is greater than e. Now, we have got a partial domain. What is the given equation? ln of ln x minus x cube whole divided by ln of ln x plus x cube. As far as numerator is concerned, ln of ln x is defined. Numerator is defined well. Defined when x is greater than e. That's what we have got. Because for x is greater than e, x cube is well defined. X cube is defined. Yes. Now, what about the denominator? We have to check for the denominator. In case of denominator, for a function to be defined, if function x is equal to numerator by denominator, it implies it will be defined when denominator is not equal to 0. ln x, this is defined. X cube is defined. But for the total function to get defined, the denominator should not be 0. That implies, this is another condition for this function x to be defined, ln of ln x plus x cube should be not equal to. We know very well that ln x, for it to be defined, it is greater than e. This value is always greater than e. And this value plus x cube should not be equal to 0. That means we have to find the roots of x is not equal to roots of x cube plus ln of ln x. Do you agree? X should not be equal to, from the numerator we got the condition that, this is one condition. Second condition, we got that x is greater than e. Now, How to find out the roots of this equation? That is the question now. Here, let gx is equal to x cube plus ln of ln x. Here we have seen that x should be greater than e. Let us see the behavior of gx. If x is tending to infinity, what happens? When x tends to infinity, gx is equal to infinity whole cube plus ln of ln x, ln infinity. It is not infinity, rather it is tending to infinity. We will write it as minus, infinity minus. For example, tending to infinity is written as infinity minus. Tending to a can be written as either a plus or a minus. Because infinity plus cannot be there, infinity itself is an infinity, we can take lesser value than infinity, but we cannot take more value than infinity. Now, this becomes as x tends to infinity, gx tends to infinity. This is one of the observations we made. Because x is greater than 2, greater than e, that means it can go up to infinity. That is one domain we have got. Now, another one, even for the denominator we have seen it. X is greater than e implies the value, a small increment of x also is greater than e. That means x tends to e implies x can be e plus small increment. It cannot be e minus because x cannot be lesser than e. X is equal to e plus small increment of value in e. Now, as x greater than e can be written as x tends to e, but x is equal to e plus some small increment. Please try to understand this. As x tends to e, meaning x is equal to e plus, that implies a small increment, infinitesimally small. Then, as x tends to e, gx is equal to, as calculated in previous exam, previous for infinity, let us calculate for e also. Gx is equal to e plus whole cube plus ln of ln e plus. Ln e plus is very small, infinitesimally small. It can be treated as ln e and it will be e cube plus ln of 1, that is equal to e cube plus ln 0, that is equal to e cube minus infinity, that is equal to minus infinity. That means gx is equal to plus infinity when x tends to infinity. Gx is equal to minus infinity when x tends to e. And for both of these conditions, x is greater than e. That means Gx has, that is x cube plus ln of ln x, because here there is a sign change, has a root in x greater than e up to infinity. That means we have found out and we have concluded without any calculations that x cube plus ln x has a root. Implies x cube plus ln x is equal to 0 has a root when x is greater than e. Let that root be, we are not calculating the root because we are only finding the domain. Let that root be x naught. Then it implies x naught cube plus ln x naught is equal to 0. What we have established is that when x is greater than e, there is a root x naught. For the value of x naught, x is equal to x naught, the equation gx is equal to 0. It varies from minus value to minus infinity to plus infinity because of this sign change. Gx value changes as x changes between e and infinity. That means denominator is equal to 0 at x naught. Hence, function x is given as ln x. What is function x is given as? Minus x cube ln x plus x cube for function x to be defined. X should be, first condition, x should be greater than e, and second condition is that x should not be equal to x naught. That is the root of this particular equation. Hence, the domain of function x is equal to domain of function x is equal to what is the domain? Domain of function x is, think over, x should be greater than e and x should not be equal to x naught. That means the domain is E is less than x naught, because x naught should be excluded. It should not be equal to x naught. And x naught x is greater than x naught and x is less than infinity. This is one part. This is another part, both union. That means domain x should be greater than E and it should be less than x naught. It should not be equal to. That is excluded. And in the other part, x can be greater than x naught but less than infinity. But x should not be equal to x naught. How to write it in a proper way? This can be written as you should understand the concept, and I think you have understood the concept. Now the domain is we can write it as domain of f is equal to, rather we can say domain of fx is equal to a set of values x is greater than E minus x is not equal to x naught. That implies where, not that implies, we'll write where x naught is the root of x cube plus ln of ln x is equal to 0. This is the answer for domain. Now, we have to go for the range. We have to go for the range. We got function x is equal to ln of ln x minus x cube by ln of ln x plus x cube. This can be written as dividing numerator and denominator by x cube. We can write it as ln of ln x divided by x cube minus 1 whole divided by ln of ln x divided by x cube plus 1. If x tends to infinity, this value becomes 0. This value becomes 0 because x cube increases faster than ln of ln x. This will be equal to 0 minus 1 by 0 plus 1. That is equal to minus 1. When x tends to e to the power of e, let us say function x when x tends to e to the power of e. What happens? ln of e to the power of e divided by e to the power of e whole cube minus 1 whole divided by ln of e to the power of e divided by e to the power of e whole cube plus 1. Are you able to understand? That is equal to ln of e to the power of e is e. That means ln of ln e by e to the power of e whole cube minus 1 divided by ln of ln e divided by e to the power of e whole cube plus 1. ln e is 0. ln e is 1, sorry. That is ln 1 minus 1 e to the power of e whole cube divided by ln 1 divided by e to the power of e whole cube plus 1. ln 1 is 0. That is 0 minus 1 by 0 plus 1, that is equal to minus. That means fx is equal to minus 1 at x tends to infinity. Fx is equal to minus 1 at x tends to e to the power of e. When x is equal to 1, what happens? When x is equal to 1, function x is equal to ln of ln x minus x cube by ln of ln x plus x cube when x is equal to 0, when x is equal to 1, rather x tends to 1, this implies ln 0 is infinity, ln 0 is minus infinity, ln of minus infinity undefined, this will be undefined. That means when x is equal to minus 1 or plus 1, it is undefined. It is not x is equal to 1, rather we can say function x is no values. X should be greater than e, that we know very well. So x is equal to 1, undefined, it is already proved that x should be greater than e. Now we can write domain as x is greater than E and x should not be equal to x naught. Or it can be written as set of x greater than E minus x naught. X naught is excluded. Range is here. For the above given values of domain, what will be the range of the function fx is equal to ln of ln x minus x cube divided by ln of ln x plus x cube. We have to find out the range here. Now, we have already calculated certain values. When x tends to infinity, because here x is greater than E. X is greater than E implies x can tend to infinity. When x tends to infinity, it implies function x is equal to minus 1. When x tends to e to the power of E, that implies function x is equal to minus 1. That means minus 1 is in the range. And similarly, involving x cube in addition to ln x. That means we can definitely say that the range will include real values from minus infinity to some maximum value function x union 1 to infinity. This is the range. Here, maximum value of function x is equal to or we can rather say is greater than minus 1 because when x is equal to e to the power of e, fx is equal to minus 1. This maximum value is found out to be fx maximum is equal to minus 0.9999 approximately. How to find out the maximum value of any function? That when we go on to the real derivatives, we will come to know. That function dash x is equal to 0, then we will be finding the x, and from there we will be finding the maximum value of function x. That we will be discussing when we do the real derivatives, finding the maximum and minimum of the functions. Now, the answer is domain is equal to x is greater than e and x is not equal to x naught root of ln of ln x plus x cube is equal to 0. This is domain. Range is equal to minus infinity and f max union 1 to infinity. This is the final value. If you have any doubt, please comment in the comment section. And regarding maximum minima, to find out the maximum and minimum of a function, given function, we'll discuss in detail in the upcoming classes. With this, I wanted to close this lecture on logarithmic functions and finding the domain and range of a function. Now, we'll be moving from next lecture onwards. We'll be moving for plotting. While plotting the other graphs, we'll take up this also in plotting. We'll plot this particular function also. Try to do something on plotting of this function. You will get some idea and we will clear the concepts in the next class. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Thank you. And if you feel there is a value addition to this, to your knowledge because of this lecture, kindly hype, share and subscribe to my channel Maths and Science by IITN. Thank you.